Hello, everyone. My name is Alex. I will be talking with you today about going beyond Copilot with AI agents. Now, before we dive deeper into AI agent world, let me quickly ask you to get to know better my audience today. Who here uses any coding assistants right now? Can I get a show of hands? Okay, and out of those who use coding assistants, does anybody use anything other than Copilot or ChatGPT? Can I also get a show of hands? Okay, just a few people. All right, okay. Now, the agenda for today is we will talk about, first of all, why we need to go beyond the Copilot, what's not so good about it, also known as past. We will also talk about how we can go beyond Copilot, also known as present. And then we will talk about what's next for you, as a developer. Will AI take over your job or not? And also known as future. So let's start with why. And to answer the question of why, let's first talk about what coding assistants are and what they promise for you to have. So usually, coding assistants do have a set of features which can fall into one of those four categories. First of all, obviously, they provide code generation capabilities, and these can be in different flavors. So it can be something you type as a natural language request, and then you get a code generation. It can also be something like code completion, where you start typing, and then you get an autocomplete suggestion on how this line should end. Regardless of the flavor, the end result is you get a code from scratch from some sort of request from you as a user. Another option is code refactoring, or in general, any code editing options, where you can ask, for example, the tool to optimize your code, to refactor your code, or modify it somehow. Or in some cases, it's just a matter of clicking optimize button, and it does some sort of magic behind the scene, and you can't even specify what you want to optimize. There is also, of course, in some cases, error detection, and in some assistants, it also can proactively help you with those suggestions on how to fix those errors. And in a sense, it kind of overlaps with code refactoring because it also usually requires you editing the code. And last but not least, of course, is docs generation, and it's any features around natural language text generation. So, for example, doc strings, or maybe markdowns, or whatever, pull request summaries, and so on. Now, all of this sounds pretty nice, and the usual promise of coding assistants is that you will be able to code faster, you will be able to code smarter, and so on. Now, of those who use coding assistant, can you confirm that that's the case? Do you use smarter? Do you go smarter, faster? I can see some no's. Okay. Well, yeah. So usually, if you just tap, for example, for autocomplete, you might get a lot of code. But unfortunately, you still need to debug it. You need to validate that it's actually working. And usually, once you get some code, it might not even work, and you need to spend time on debugging it. And that's actually the case based on the several studies done by different companies. So while there are definitely some pros of using GitHub Copilot and similar tools, like for example, developers reported that they completed task faster, they perceived some increase in productivity, and felt more confident about the code, even though Copilot they would tend to produce a lot of bugs. But still, if you look at the bigger picture, at a longer time frame, unfortunately, things like code churn or code renewal rate has increased or even doubled. So basically, the code which was generated by code assistant was either deleted or modified, refactored in the span of 2 weeks. And yeah, a lot of code completions also required heavy modifications from the developers, which essentially means that you are not saving time. You're actually spending maybe even more time on understanding what the hell is written in this code. Now, why does this happen? Well, LLMs, by their nature, are trying to predict the next most probable token or symbol, and it's all good as long as you work. You code something that is similar to what was in the training data, and LLMs are usually trained on open source data. So as long as your code looks similar to what has already been written, all good, and you probably will get good results. However, let's imagine a scenario where, let's say you have a unit test written using unit test library, but then in open source data, PyTest is the most prevalent library. I don't have the actual statistics, but let's say for the sake of argument, that PyTest is the most common library in the open source data. Now, when you try to use LLMs to generate a test for your specific code, we use unit test. Unfortunately, LLMs will fail because it's so PyTest already, most probable symbol, most probable library, so it will try to use PyTest instead of unit test, and well, you are pretty much becoming not so happy about the results. And things go even worse if you have some sort of your own test framework or whatever your own framework inside your company, because LLMs basically have no knowledge of this framework, and they can't give you any advice on how to use it. They can't even use it for your benefit. Yeah. So, what are the reasons there for current LLMs failing? Well, first of all, they do tend to struggle with some logical reasoning, and they tend to struggle with some facts which might be phrased in not so a straightforward way. So, for example, Tom Cruise is the mother's son. It does sound maybe a bit quirky for for the human ear, but still we understand what it means. Unfortunately, LLMs tend to fail on those sort of quirky sounding things. So in this case, for example, it clearly states that the surgeon is the father's boy, but unfortunately, LLM does fail that saying that the surgeon is actually other father of the boy. And as you can see, it's not even just a regular ChatGPT, it's a O1 preview, which is supposed to be much smarter and much better, and it thought for 10 seconds for that answer, and unfortunately still failed to produce good results. And so yeah, even the latest and brightest models tend to fail, tend to hallucinate, but it just takes them a bit longer than for the regular LLMs. Now, another problem is models don't have grounding in the physical world. And what I mean by that is that they don't know anything about your code base, about your libraries, especially if you have some sort of internal frameworks, internal libraries. They can't check what kind of environment you have locally on your computer, what kind of Python packages, what kind of build tool use, and so on. And they can't utilize this knowledge. They can't run those tools, and so on. So basically, you can compare using coding assistants with the case of 50 first dates, or well, 50 first tasks, where you basically take a random person from the street, a random developer from the street. You see him, her in front of the computer, and ask them to basically write a code for you, or solve some task from Jira. And unfortunately, you don't give them any context of what kind of libraries you have. Maybe you have some sort of internal frameworks which you need to use. You have some sort of guidelines and so on. They don't have any knowledge about this, so they already missing some context needed to solve the task. And that's pretty much the case for the current generation of code assistants. They don't have any specific knowledge, specific context of what you have in your code base, in your company, and so on. So they lack context, which means that LLMs might try to hallucinate something, some sort of framework, some sort of function, and so on. And this also produces an incorrect code as a consequence of that, and this makes you as an engineer not so happy. And then you basically do this over and over. Every time you ask the coding assistant to do something, it's akin you picking yet another random developer from the street, sitting them in front of the computer, and repeating this process over and over. And then the last one, of course, as I said, they work well in distribution. So basically, as long as your tasks, or what you're trying to achieve, what you're trying to generate, is similar to what was in the training data, in the open source data, you are golden. But then, unfortunately, once you start, importing your own frameworks, your internal company frameworks, everything starts to fall apart because LLM, don't have any knowledge about this framework, and it can't properly utilize any maybe functions from that framework and so on. Now let's diverge from LLMs and talk about you as developers. So there was a study in 2015 on how developers spend their time, and who can guess what is the most time is spent on? All right, and work-related? Okay, trying bugs. Reading, yes, exactly. Understanding, essentially. This is what I called understanding. And as you can see, actually editing the code is only 5%. And current coding systems pretty much ignore all the rest of 95% of the time you as developer spend in your work. They just focus on those 5%. So to get a better coding system, to get better help from those coding systems, we need them to focus not just on those 5%, but ideally on all those 100. But already understanding this part of understanding, it will give you a tremendous help because it will also make the editing part or code generation part much better because it will not just blindly generate code, but it will understand why and what it tries to generate. So now let's talk about how we can achieve this. Well, let me introduce the notion of AI agents. So AI agent is a software that basically performs tasks on behalf of the user, and this probably does sound sort of like what coding systems do right now. But what differentiates AI agents is several things, or several design patterns, if you will. Now, there was an interesting comparison of AI agents to Roomba, which can only point to the patches of dirt on the floor, but can't really clean them. And that's not really helpful, right? And that's probably very annoying. So let's think what this kind of Roomba would need to be able to help you to clean the dirt. So if we think about Roomba as a software running on the vacuum cleaner, it also has access to the tools, right? So it has some brushes and so on. It also can do some planning. So it don't just randomly scatters around the floor. It follows some sort of pattern based on the floor plan and what it thinks the best way to cover that area. And those two are already things that can help coding systems, and those two are one of the 4 sort of design patterns. So tool use over here. So first of all, obviously LLM ideally would be able to get some sort of knowledge from the web. It can get some knowledge of your own tools. It can use those tools to get better results and so on. Ideally, we also want AI agent to be able to plan something. It's not just blindly start doing some stuff, but first think about what needs to be done before we can get the results. There is also an notion of reflection. So we don't again just get the plan and execute it. We try to AI agents need to try to understand if that plan is good, if there are any fail points, and so on. And we also can have the multi-agent collaboration. So let's say one agent is sort of like backend developer, another agent is front-end developer, and they can interact with each other with the goal to produce the end and project end result. Now let me get back to this diagram. And if we think about those design patterns, we actually can find a lot of overlap with those parts. So first of all, tool use. Well, obviously we use tools for editing, right? For coding, we use tools when we are outside of IDE. We can do some web searches, use browsers, use debugging tools, and so on. And obviously UI interactions also is pretty much a tool use. Now, second part, planning. Obviously, we all do some planning. We don't just blindly start typing something. Even subconsciously, we try to first plan, okay, I will do this thing first and the second one and so on. So we already have a planning here as well. Reflection. We all, well, not all, but usually we work in teams. So we can interact with our peers, we can talk with each other, discuss our plans, reflect on them, and come up with a better solution. And, well, multi-agent collaboration pretty much is the same as working in a team. So we might have, product manager, we have the front-end developer, back-end developer who work together with the same end goal to achieve the best product, I guess, possible. Now let's actually do some coding. So let me try to zoom in here. So over here, I have a small piece of code which essentially just queries the model and tries to get some results from it. And this is pretty straightforward code, and all of this code is available online if you want to try it out. I will show the QR code later. But basically, we just start an OpenAI client to interact with GPT-4 model. Here's a small function which will allow us to essentially send our messages to GPT and get results. And let's try some examples. So let's say we want to know what's the response time for Google. In the real world, we would use something like ping. Unfortunately, of course, LLM can't do that. Let's hope the internet won't fail me. And yeah, so as you can see, obviously, LLM doesn't have any access to ping or whatever, to internet connection. So unfortunately, it can help us with that. Now, let's try another one. So what kind of Python packages I have installed? Again, LLM obviously doesn't have access to my computer, and this pretty much limits its ability to help us with this question as well. Yeah, I don't have access, so pretty much expected. And let's also maybe try asking what's new in Python 3.14. I know this not yet has been released, but there is already 3.14 A0, I think, version available, and with the description of what's new in Python 3.14. But unfortunately, again, LLM doesn't have notion of this new Python version because, and hopefully it will answer me the same. Yeah, OpenAI can, okay, yeah. Yeah, again, as you can see, the knowledge of the LLM is limited to pretty much last year. So obviously, Python 3.14, which hasn't yet officially been released, is not part of that knowledge. So LLM tried to hallucinate something. There is some sort of new syntax additions, which I'm not sure where it came from. And obviously, if you think about how this applies to your everyday life, when you use coding assistants, you might get some sort of hallucinations, you might get some sort of bugs which you might miss when you overlooking the code, and this gets into production. And then if you think about these churn rates and being increased, that's one of the reasons why it happens. And the last one, well, let's see who are the speakers at PyCon Portugal 2024. And again, no information about this, unfortunately. So yeah, not so helpful. Akin this Roomba, which can only point to the dirt. But now let us give our LLM some tools. So what I'm using here is, again, pretty much the same client. But now I'm using this so-called React framework. React stands for Reason plus Act. And this framework was introduced 2 years ago. And it consists of essentially us conditioning LLM to follow 5 steps. First of all, LLM needs to produce a thought on what it needs to do to get the task done. Then it can decide which action it needs to perform based on this thought. Then there is a step of pause, where essentially this action is being executed. And after that, there's a step of observation, where LLM observes the result of action execution and plans any subsequent actions based on that. Ideally, it can get an answer, but if not, it might go in the same loop of, okay, so I got those results, now I need something else, and get new action, observe, and so on until it gets an answer. And this can be realized pretty much with this system prompt over here. So this is essentially what I'm asking the LLM to do. You're running this loop. First, introduce the thought of what you want to do. Think about tools you want to use, and then we give the LLM a set of tools. In this case, it's tool called ping, which essentially pings website introduced by LLM. There is bash, which allows LLM to execute any bash commands on my laptop. And there is web search, which essentially does the web search and gives the LLM the result of this web search. And I also introduced some example sessions. So a question is essentially a user query. So I'm asking how many islands make up Madeira. Then LLM should produce a thought. Okay, so I need to do a web search. There is an action for web search about Madeira. Then there is pause when this action is supposedly happening. And in the end, LLM gets an observation and hopefully gets an answer, hopefully gets a correct answer. Now, let's quick close a look here. So I have the query model again, and I have those three functions, which essentially do those actions I just described. So ping, it just essentially tries to send a GET request to the website and return the total seconds elapsed from this request. Bash essentially just executes a command, and quick note: don't just blindly execute a command. This is just for demo purposes, but you don't want to blindly execute any commands on Bash, obviously. And the web search, in this case, I just return the first URL from the search, basically, and clean up all the HTML stuff over here. So to remove all the tags and whatnot, just to get the LLM only the text instead of all the tags from HTML. So let me note that, and let's verify that it works. So let's do ping, let's do bash, and let's do web search. So lately, so as you can see, we're using this URL, and here's the text about Madeira over here, quite a long text. But somewhere here is also an answer about the islands. I won't be looking for it right now. Now, we basically just a helper sort of dictionary of known actions. And here where the things get interesting. So this is our query function, which basically runs the loop of React, loop of thought, action, observe, and so on. So it's pretty straightforward. We first query the model with this system prompt and the user prompt. And then we try to detect which action LLM wanted to do. We basically execute that action, get the observation from that action, and then send that along with the previous messages to the LLM. And we do that in the loop, just in case the first iteration is not enough to answer the question. So let us now try to see what's the response time for Google, and if LLM will be able to answer that right now. Oh, sorry, I didn't execute the system prompt. My bad. Let's try again. Yeah, so as you can see, it got into the first loop. It thought, okay, I need to execute the ping. It called essentially the action, ping google.com, in the same format as we asked it to do. We ran the ping, we got observation to LLM, and now LLM can answer us our question about what is the response time for Google. Let's check the same about interaction with our environment. So what Python packages do I have installed? Well, in this case, LLM thinks that we need to execute pip list command, which is essentially what it does. So it tries to do the action bash pip list, which returns the list of packages. And let's see. Yeah, we got the answer that we have a bunch of packages, and here's the list of them. And in this case, I won't be checking, but I would imagine that LLM didn't hallucinate based on the actual list of the packages. Now let's check if we can get a new knowledge to LLM, for example, about this Python 3.14. So yeah, it decided to do a web search. And as you can see, here's a link to this 3.14 what's new page. And now here's the observation. It's just the content of the website. There are some new features over here. And let's see what LLM answered us. Yeah, so that was enough for LLM to answer. And here now, OpenAI GPT-4 can give us the exact answer on what's new in Python 3.14, even though the LLM itself was trained on the data pretty much predating any notion of 3.14. And let's check who are the speakers. And again, in this case, we do the web search. Here's the content of the website, and yeah, so we can LLM can now also answer us the question, answer to us about events happening right now. So essentially, all the speakers over here are based on the website. Now, let me switch back to the presentation. Okay, so as promised, you can find all those notebooks here on this QR code, and obviously you can imagine that those actions can also be not just simple functions like bash or web search. They can also be agent on their own, and you can see how it can lead to multi-agent collaboration essentially where a top LLM has a sort of army of agents which are backend developers, front-end developers, managers, and so on. And then each of them is asked to perform some action, and then those actions itself can have some sort of tools, or maybe even more agents under their belt, and they, you can see where it goes. You get this sort of chain of agents essentially, all working towards one goal, decomposing the task into smaller chunks and executing it one by one. Obviously, there are also some open source tools which can help you, not just define those actions, define those agents from scratch. Some of the most notable ones, some of the most notable open source tools are SV Agent and OpenHands. OpenHands is formerly known as OpenDevin. So you might have heard about Devin, which was still is a tool which was introduced, I think, last year, and they had a big demo of Devin solving the Upwork task. So OpenDevin, or OpenHands now, is essentially the sort of open source attempt to replicate the Devin promise, but being open source. So of course you can also use those tools to get you started on using agents in your everyday life. But of course, well, we as Encoder, you can. We also give you the option to start using agents without any hassle, without you doing any effort on trying to implement your own stuff. So let me talk a bit about us, about Encoder. So we basically leverage AI agents in the code generation and code assistant way to give you the better results, better code generation. So let's revisit this 51st date scenario, where in our case, instead of just blindly taking this developer from the street, we give this developer a lot of context, a lot of knowledge about your code base, some internal tools, and so on, about your environment, about the environment of your project. And this already leads to much better result in the generations, because LLM now has more knowledge about your code, about your internal guidelines, about your frameworks, and so on. But on top of that, we can also do a lot of agentic improvements. So I will show some demos in a second. But essentially, what we do is we don't just blindly generate the code. We also try to do some checks on top of it. Because LLMs, even though there is less hallucinations, LLMs still tend to hallucinate, introduce errors, introduce bugs, and we want to give you the best compile-ready code possible, which you can just essentially commit to the repository and hopefully not churn in 2 weeks. So yeah, let me give you a couple demos, couple videos. So first thing is unit test generation. And those who tried Copilot, you probably know that you can also, for example, in Copilot, you can ask it to generate unit tests in the chat, and it will start streaming the code right away. And probably even not knowing which framework you use, which obviously can be quite daunting. Now, in our case, let me zoom in. Once you click this generate unit tests, again, we don't just start streaming the code right away, like Copilot would do. We first generate what is called unit test proposals, essentially a test plan where we define what we want to test. And it looks something like that. So yeah, as you can see, you can also edit the test cases, or you can add your own test cases in case you want to test some sort of specific corner case, which we didn't cover, or maybe you want to test something specific, some sort of specific value. Now, once we hit start unit test generation, again, as you can see, we don't just stream the code right away. Obviously, we do generate the code over here at this step. But then we run what we call a repair pipeline on top of that code to make sure that it actually runs, it actually compiles, and basically that code that makes you or your unit test happy. And yeah, you can see we do some syntax checks, we try to run it, and at each step we try to fix errors which might arise, so that in the end we get the unit tests which actually work and which you can actually use and commit right away. Sorry. But that's obviously not all. You can also leverage this repair pipeline, those repairing agents, in code editing or code generation features. So, for example, in this case, I have this code improve feature, which essentially you can ask the encoder to optimize or edit your code in some way you want to, So in this case, I have this extract claims from JWT function, which is written basically using built-in libraries, base64 in JSON, which I guess is fine, but we can also rewrite this using JWT library. So we can use libraries specifically designed for working with JWT tokens. And we essentially will ask the encoder to do exactly that. So let me just pause here for a bit. So yeah, we're just asking to write the code using JWT. And once we hit enter, again, as you can see here in the corner, we don't just generate the suggestions. We also, once we get the code, we also try to repair it. So we try to run it, we try to do some syntax checks, and so on. And in the end, as you can see, we removed unnecessary imports because we no longer need base64 and JSON libraries. But we need a new import for JWT library. Oh, sorry. And let me scroll back here. And the function which we initially tried to optimize is essentially now a one line of code, which is much more maintainable and easier to read and understand. Okay. Now, what's next with all those new tools coming up? What happens to you as a developer? You've probably seen some headlines that this tool will now replace all developers. Nobody should go into IT and so on. And that's one way of looking into that. In some cases, it can be a good thing. In some cases, it can be a bad thing. Because there is a lot of hate from artists, for example, about AI tools. For programmers, it's depends. But I mean, even if the ChatGPT will replace us, you can always go goose farmer. And I guess that's or whatever your heart tells you to do. But not everything is so gloomy. So obviously, first of all, the model can't work without data, so you obviously always can try to generate data for ChatGPT, generate training data. But seriously, I think the better way to think about this is you would not just be using some sort of tool; you would be collaborating with it, right? So as I mentioned in the example, when I showed some code. You can imagine that you have some sort of army of interns or junior developers who you can ask to do some sort of mundane tasks on your behalf, or even better, you might have some sort of even full-fledged company consisting of managers, virtual company obviously, consisting of managers, developers, DevOps people, and so on. And you can ask them, you can delegate to them any tasks you want, and they will essentially collaborate with you on maybe defining some requirements or updating them, and in the same time executing the code, creating the code so that it fulfills your initial task. Yeah, so again, our tool is currently in closed beta. We will go public in the next couple of weeks. Until then, you can join us, you can try us out using this QR code over here. Join the waitlist, and I will make sure you get an invite. We also have a booth on the left of the auditorium, and you can find me or my colleague Artyom. We are pretty noticeable, and I guess that's because of the color of the t-shirt. Yeah, so I hope that was helpful for you, and hope that it, helped you understand that we won't get replaced anytime soon. And yeah, happy to answer any of your questions.
Thank you so much, Alex, for the talk. Oh, yeah. Some hands.
Thank you very much. That was so cool. You blew my mind. I've been very skeptical about all these chatbots, but that was really cool. Thank you. I noticed your research was from 2015. I mean, the cynical part of me was like, well, that's just classic AI companies looking at stuff. But it's quite old. Do you not think things have changed since then, programming over the last 10 years? Yeah, that was my question. Thank you.
Yeah, that's actually interesting because just yesterday I saw a new study which said there was a company which essentially asked around, I think, 800 developers to use Copilot, and they compared the output for 3 months before using Copilot and then 3 months of using Copilot, and they didn't find any benefit whatsoever from using Copilot. Essentially, they didn't work less, they didn't produce more code, they didn't produce more pull requests, and so on. But at the same time, this article, they refer to another company which introduced GitHub Copilot, or maybe it was some other code assistant, regardless, and they saw indeed the boost. So, there is still some evidence for and against, and I guess it also depends on how you use those tools, right? Because essentially garbage in, garbage out. So if your request to LLM is not so good, maybe you just asked it, with one word. Obviously, it won't be able to help you. But if you write a better prompt, if you write a better, question to the LLM, it might get you better results. Or in the case of Copilot, better code. But again, still, kind of prompt engineering is essentially in a bit of art. And if you want to get the best of those tools, you need to kind of master this art, in a sense.
Hi. Hello, is this on? Ah, it is. Hi, fascinating talk. You kind of half answered my question just now, but I was going to say that it seems that a lot of our job in the future is going to be prompt engineering, in which case the quality of the code that's produced isn't so much down to the LLM, but down to the skill of the person prompting. And there have already been studies made about this, where if you give inexperienced programmers an LLM and they ask stupid questions, you're going to get stupid code out. So, well, anyway, there's still going to be a human in the loop to make things difficult. So my question was, and you kind of touched on it just now, you talked about the quality of the code. How do you judge that quality?
That's a good question. And there are some tools where you can which you can use to assess quality. And there was another, again, study, I think a couple years ago, where they tried to classify the code based on how hard it was to modify the code to get into production, like how much time it took the developers to modify that code, to push something, to create a pull request. And based on that, they essentially, this research introduced a tool which was based on code smells. You probably heard about code smells, so like complexity of the code, like a number of branches, or in the if-else statements, and so on. So that's one way of creating some sort of metrics which can check the code. Another option is to use another LLM to check if the code is good or not. Obviously, this is still prone to errors as well, or hallucinations, but that's one of the current sort of directions, so-called LLM as a judge, where you can ask other LLM to assess the output of the first LLM and see if it's good or not. And yeah, speaking of the jobs and the future, obviously, the job of the developer will sort of shift more towards reviewing the code generated rather than writing it. But it doesn't mean that you don't need to be a good developer to properly review the code. Right? Because if you are not so good developer, if you don't know how to code, you can't properly detect bugs, you can't properly detect errors and whatnot in the code. So I don't think it would just boil down to prompt engineering, right? Because you still need to overview the results of the code as well. And indeed, human in the loop never say never, but human in the loop will still be there for some time, obviously.
Hi.
Hi.
I didn't saw the whole presentation, sorry.
Okay.
So I might be missing something, okay. But it's about references. So what I mean is you have a methodology, which is quite interesting, right? Because you have URLs and all that stuff. And sometimes you get code out of nowhere. But that code comes from somewhere, right? You rationalize over it, be it Stack Overflow or GitHub. Do you provide those references to the programmer? Because I can imagine, and with the human being in the loop, right, he can go back and even grab some more context, because the context you presented, it's interesting, but it's not presented in your tool, I believe. I didn't try it. So do you give those references something you were thinking adding? Or
Yeah, so we don't do that right now. We did discuss several options on that regard. So, for example, things like checking that the code falls. Well, if it's the same code as the open source code, checking if the license is good. If it can be used or not. Right now, we don't do that, but that's definitely on our roadmap. To give you better information, to make you safe, feel more comfortable using it. Because obviously you don't want to get some sort of code which is licensed under, copyleft or whatever license into your code base, which can imply, sometimes bad things, right? And that's definitely on our roadmap. But right now we don't, provide any reference.
Hello.
Hello.
Thank you for the presentation. Considering traditional machine learning algorithms, that if you train them on predicted data, they'll start losing their quality. And considering these algorithms, these LLMs rely on scraping the web. Currently, we are seeing some websites closing their doors to LLMs, and we also see a huge influx of low-quality answers that are written by bots, commented by bots. If you go on Google Images and search for baby peacock, you just see AI-generated images. What do you think will be the future of these algorithms as time goes on, as the internet starts to become garbage?
Yeah, that's a good question. It kind of partially goes beyond the talk, but there are obviously some recent studies which you can find where they sort of check how the quality of the model deteriorates or improves based on the training the model on previously generated data versus training on the human-generated data. And indeed, model do deteriorate in quality even quite significantly if they get trained on the data which was predominantly generated before them by another model. And I think that's another sort of part joke here. That obviously, LLMs right now, at least, they can't produce code completely from scratch, right? You still need to have some sort of human in the loop, and you can think about this in several ways. It can be something more simple, like simple labeler jobs, but it can also be something more sophisticated, like writing the code from scratch, more complicated code, and so on. And I think in the future, indeed, we will have a problem with this data being more and more generated rather than genuine data from people. So yeah, I think we will need some way to sort of get this data filtered out first, and then get better, higher quality data, which can also be part of the this human in the loop notion, where people generate data and LLM use that data to give you much better results and much more data.
Thank you very much. It was very interesting. I really enjoyed also the initial part about the agentic patterns, and that was very clear. One thing that I noticed by using some of these patterns is that so some of the limitations are mostly on the side of performance, and especially when using third-party services, is about like getting throttled because at the moment the rate limiting is insanely low for most services, and they provide you with like some things like, I don't know, interregional ping pong or stuff like that. However, I mean, making so many LLM calls can be seen as a limitation of the pattern. So this is just a curiosity. What do you think what is the way forward? What do you think is going to happen to mitigate that issue for any non-trivial use of the agents?
Yeah, that's a good question. And I guess there are two parts here. So first of all, obviously you can use local models as long as your hardware allows you to do that. Like on some modern MacBooks, you can run Llama 70B, I think, or 34B, which can produce decent results. They won't be as good as ChatGPT, right? But still, it will be run locally, and it will probably might be much cheaper. But at the same time, if you look at how the cost of running LLMs progressed and how the models progressed, you can see that the cost pretty much reduces in half every half a year, right? So if you compare the prices right now for ChatGPT versus the prices for GPT 3.5, it was quite a big difference. And the current model, it runs faster, it runs much better and gives you better results. So if the trend continues, we will see much more powerful models, much faster models, even on the server side, but which will be still cheaper, and you will be able to use them much more frequently. So I think going forward with this trend, I think this should elevate the issue of a bunch of LLM calls indeed.
Cool. Any more questions? No? Yes, that's it. Thank you so much for the great talk. I really like the memes.